Hello class, Mr. Calvin here again, and today I am going to introduce you to a very new topic which are called the basic trigonometric ratios, or simply called basic trig ratios. And we're going to be using functions on our calculator that you have never used before. So if you have your scientific calculator in front of you, please have it handy, because I am going to do a quick introduction for you so you can go through this lesson and get the exact same values that I have in the lesson. All right, because again, what's important with today's lesson, like I said before, it's going to be all dealing with the use of a calculator. So it's very important that you follow along with your own calculator to see where the keys are on your calculator and the order that you need to press keys in. Now, for the most part, if your scientific calculator is relatively new, okay, chances are you're just going to put the information in exactly the way that I present it in the lesson. Okay, so my calculators that I have in class, that does it, and most calculators you can buy out there do it as well. All right, so when we're dealing with the trigonometric trig ratios, I'm just going to call it that. Okay, there's actually three. We're going to focus on two for today. Okay, and what we want to do first is to introduce you to the keys that we will be using in this entire chapter, because again, you need to know where they are as well as the order that you press them in. Okay, so when we're dealing with the basic trig ratios, okay, the first two we're going to look at again are the sine and cosine ratios. And basically what we're going to do here, you can only use the basic trig ratios when you have a right angled triangle. And we can use the sine and the cosine ratios, and later on we're going to talk about the tan ratio, okay, to solve for the length of side lengths, okay, as well as to find the measures of angles. Again, it's only for right triangles. So remember, in the first lesson in this chapter, we revisited the Pythagorean theorem. So we did that so you can understand what the different parts are for the right angle triangle. So the formulas for that, okay, are going to be the following. And I put a red box around the angle A there because that's going to be with respects to the angle A in this particular diagram. Okay, so what you're going to see here is that when you're looking at this, what's called the sine ratio, okay, the formula for sine ratio is opposite over hypotenuse. Now, remember when we did the lesson on the Pythagorean theorem, the hypotenuse was always the side directly across from the right angle. Okay, so what exactly is the opposite side? When we're talking about the opposite side of A, we're looking at the side directly across from it, like this. Okay, so whatever letter that is given in the formula, okay, the side opposite to it is the one directly across from it. Now, as I said before, the hypotenuse is always the side directly across from the right angle. Okay, so I just want to distinguish the difference between the hypotenuse being the opposite of the right angle, and the side that is opposite being the opposite of the given angle in a right angle triangle. Okay, now the cosine of A, okay, or written down as the cos of A, is given the formula adjacent over hypotenuse. Now, as I said before, the hypotenuse is very easy to find, okay, because it's the side directly across from the box there. Now, adjacent is just a fancy word for next to. So if you take a look at where angle A is, the side next to it, okay, is the adjacent, okay? Now, talking about this diagram here, it's going to be a little different if you're looking at angle C. Okay, so if we're looking at angle C over here, which I'm going to indicate with the blue box over here, or blue circle, okay, then it changes. Okay, first of all, the hypotenuse is always hypotenuse because it's the side directly across from the box. If we're taking a look at angle C over here, the difference between the opposite and adjacent is the fact that they will be switching locations here. So for angle C over here, okay, the side opposite to it is actually this one over here. Okay, so this would be the side that is opposite to angle C, whereas the adjacent, okay, that would be this one. So that's the difference between the two. Now, common question is, how do we know which one is which? Okay, just remember that the side that is opposite to a certain angle, okay, is the one that is directly across from it. That's why I've labeled this for angle C over here. The side across from it, okay, that's going to be the opposite in that case here, for this one here. And this would be the adjacent there, all right? So that's just to distinguish it. And again, once we go through more examples, okay, you'll get accustomed to labeling the sides in that manner. Now you're going to see that when we're dealing with today's lesson, I'm always going to label the hypotenuse first because it's the easiest one to identify. Okay, so just as we go through that, we're going to approach it in that manner for this lesson. All right, so the next thing we're going to do here is just, again, familiarize yourself with the calculators here. So if you take a look at your calculator, okay, it may or may not look like this. Okay, this one over here is the same layout as the ones I have in class. Now, the first thing we want to do here is we want to make sure that the calculator is in the right mode for us to get the right answers that we want. So you have to make sure your calculator is put in what is called degrees mode. Now, I repeat, if your calculator is not in degrees mode, you will not get the same answers that we're getting in today's lessons, okay, and for your test as well. So all the examples we'll be seeing in this particular chapter, you must make sure your calculator is in degrees mode. Now, depending on what calculator you have, okay, on my calculators, you just have to press the DRG key to get there. Okay, in some cases, if you reset your calculator, and that usually is a button on the back that you can poke with a pin or something. Okay, when you press that, it'll automatically set itself to degrees because it's the most commonly used method. Now, the keys that we're going to use in this chapter here are ones that you have never used before, and it's ones you're probably staring at and go, what in the world are these keys? Okay, that's the sine, cos, and tan keys here. Now, today we're only going to focus on the first two, which are the sine and cos, and then we'll worry about tan in the next lesson. And basically, these are the keys that we're going to use to solve for either the side lengths or the angles of a right angle triangle. Okay. Now, the last key I just want to introduce you to, we've used it for other functions. Okay, but we're going to, you also need to do it for this one, which is a second function key, which is usually on the top left-hand corner of a calculator, and it's usually a different color than the rest of the keys there. So make sure you know where those keys are. In some calculators, it's called shift. Okay, but most calculators call it the second function, which is designated with a second F. And again, it's usually yellowish and green, yellowish and orange in color there. All right. So let's take a look at how to use the calculators first. And the first thing we want to do is to make sure that our calculator is in correct mode, which is degrees mode over here. So if you punch in sine 47 in your calculator, okay, and like I said, if you have a newer calculator, just punch in it the way you would, like that. Okay, and you press equals. Okay, you'll get a bunch of numbers, but when you're expressing your answers here in between, keep it to 4 decimal places. Okay, I don't need more than that, but the same token, if you only put it to 1, then your answers will be inaccurate. Okay, if you try cos 63 and you get 0.4540, okay, you're in good shape there. All right. Okay, the next thing I just want you just to get accustomed to, okay, is when we're solving for angles, is that you need to press an additional key in order for you to do that. So I've actually broken it down for you in this example. So for example, when you're solving for an angle, you have to take what's called the inverse sine. And the way you do that, in this exact same order that you're going to see in this lesson here, is you're going to press that orange yellowish second F key. Now, when you do that and press sine, your calculator, okay, should have this on the screen. Okay, so this part over here, the calculator does that all for you. Now, in brackets, put in the 0.9613 and then close the brackets. Okay, and then you press equals. Okay, you will get an angle, something point something. Okay, just round it the nearest whole for our examples for today. Okay. Now, same thing with the inverse cos. The only difference with this one is that when you take the inverse cos, you press the second function or the shift, whatever your calculator has, and cos, and your calculator will automatically give you the cos to the -1 here. Okay, so you don't need to punch that in your calculator because your calculator will do it for you. Okay, and in brackets, put in 0.06976, and you should get roughly around 86 degrees. All right. So as long as you got these numbers that I'm going through in the example right now, you're in good shape. All right. Okay, let's actually look at some problems here. And the first set of problems we're going to look at is we're going to use the sine and cosine ratios to solve for side lengths. Okay, so when we're doing these examples here, you notice I have a set of steps here that's should be relatively easy to follow. And we're going to do it exactly the same way for every question that we're dealing with in this lesson as well as for the rest. So step number 1 here is label the sides with respect to the given angle. Now what this means here, you notice that the angle given to us here is 57 degrees. So when we're labeling the sides for this one over here, for opposite, adjacent, or hypotenuse, okay, we're always going to be referring to this angle. Now, step number one here, okay, I always tell people to label the hypotenuse first because it's the easiest one to find. So if we have here the box, okay, and you look across from it, this 15, that's going to be the hypotenuse, okay? We can't argue that. Now, question is, what is A going to be, the opposite or adjacent? And as I said before, a side that is opposite to an angle that is given to you, okay, directly across from it, okay, that's going to be the opposite, okay? So the opposite, again, is just a side that is directly across from the angle that's given to you in the question. Okay, so that's that would be the next step there. So we've labeled the sides. Now, once you've labeled the sides, step number two is to find which formula or which ratio has those sides identified. So between sine and cos, if you take a look at those formulas there, notice that the sine has the opposite in hypotenuse. Okay, so when you figure that out, okay, and you determine that that's the ratio you're going to use, okay, write it down. Okay. So now that we've labeled the sides and identified what tool we're going to use, next thing we want to do is put in the numbers. So in the next step, you're going to put in the A for the opposite and 15 for the hypotenuse. Now, this 57 degrees, that's going to go in for this capital A that's in the formula here. So the next step is going to look something like this, okay? Now, I'm going to do something here because if you set it up this way, it's the easiest way to solve for the side length because, again, it only requires you something that we did when we were doing similar triangles, and that's cross multiplication. And what I like to tell people to do is to take the side with the ratio and just put it over 1. Okay, and from here you can see what we're going to do is cross multiply. And when we do that, the A multiplies itself to the 1, and the 15 multiplies itself to the sine of 57. Now, just take a moment to take a look at what I've written in this next step here. Please make sure that you have it in that order. Okay, so when you multiply the number in this case to, in this case, the sine of 57, make sure it goes in the front. Now, with the calculators that you have, okay, especially the newer ones, if you punch in the answer in your calculator exactly the way you see it, you should get the answer that we're looking for here, which in this case here is going to be 12.6. Okay, you can actually do that all in one step because your calculator will do it for you. Okay, so again, make sure that when you're taking a look at right angle triangles, label sides first. Okay, label the hypotenuse first, okay, because there's a number there, and then determine what the other side will be. Okay, so a side that is directly across from the given angle is always opposite. And remember, adjacent was just a fancy word for the side that's beside it, side beside the angle. Okay, so let's take a look at another one so we get more practice. We get accustomed to seeing this here because this is, again, a new topic for you. So let's take a look at this one over here. This time we have an angle of 65 degrees. We have a 20 meters and a B. Okay, so again, step number one, we label the sides. Okay, and notice we do have a hypotenuse here, which is 20. Now, a couple ways you could approach this, a couple strategies, I should say. So remember in the previous example, okay, when you're labeling the sides as opposite or adjacent, notice that this is the angle of 65 degrees here. If I look across over here, this would be the opposite, okay? But notice since there's no number, okay, there's really no need to label it. So if the opposite here is missing, okay, the only side remaining here is this side here, which is the adjacent. Okay, so in this case here, what we would have here would be the adjacent. Okay, so remember, adjacent is just a fancy word for the side that is next to the given angle. Now for this one here, adjacent and hypotenuse, you now need to pick the ratio that has adjacent and hypotenuse. Okay, and then what we have there will be the A. Okay, or the cosine of A. Okay, and just like the previous question, put the numbers in. Okay, and this step over here where you put it over 1, I should have mentioned this earlier. Okay, you only do this step when you're solving for the length of a side. Okay, so I just want to reiterate that because in the next set of examples, okay, we will not be doing that step. Okay, so just keep that in mind. All right, now when we get to this step, okay, we cross multiply. Okay, and then from here you put in your calculator exactly the way you see it, and you should get 8.5 meters. Okay, so we've seen two examples already. Okay, both of them involved using the sine, and the other one involving the cosine. So the next basic example I want to look at, okay, we're going to approach it the exact same way, but I want you to just make a note of this one because this one is different from the other two that we looked at in terms of the algebra behind it. Okay, so notice we have 25 degrees, we have C, and we have 9 feet here. So again, we have the angle of 25 degrees we have to keep in mind here. Now, when we're labeling the sides, okay, remember that you should label the hypotenuse first. So let's do that. So you can see that the side directly across from the box is the letter C itself, okay? Now, when you're looking at the location for the 9, okay, you first have to take a look at the angle here, which is the 25 degrees. Now, if you take a look at the 25 degrees, okay, and remember that when you're trying to determine whether a side is opposite or adjacent, remember that the side directly across from the given angle is always opposite. So for this one over here, notice I'm going to use an arrow just for reference here. The 9 feet here would be the side that is directly across from the 25 degrees. So this here would be the opposite, okay? So we've seen this before because we've used the sine ratio before, but this is how this question is different than the other two. Okay, notice when I put in the numbers, we're going to have something that looks like this. Okay, so all I've done there is I replaced the angle in for the capital A in this case. Opposite here is the 9 feet. Hypotenuse here is the letter C. Okay, now same set of steps. We're going to take sine of 25. I'm going to put that over 1. Now this is where this question here is different from the other one. When we cross multiply, okay, we're going to multiply the 9 to the 1, and the C is going to multiply itself to the sine of 25, and it's going to look something like this, which looks very bizarre. Now, I want you to just make a note of this next step here, because this next step here, okay, is basically an algebraic step, but just using something that is different. What you have to do in this step over here is you need to divide both sides by sine of 25. Okay, so if you remember when you're solving for a letter, it's very similar to that. And the reason for that is because if you take a look at the sine of 25s on the left side over here, okay, they wind up canceling out. Now, what you can do in your calculator, you can actually do it from this step, is if you take 9, okay, and you divide it by sine of 25, and when you press equals, it will give you the answer here, which is 21.3. Okay, so again, make a star, just make a note of this example because this example was different from the other two only because of the algebra behind it. Because for this one over here, notice that we had to divide both sides by the sine of 25 in this case in order for us to have the C. And the only time you do that, okay, is after you cross multiply. Okay, you notice that what you have attached to the letter you're solving for happens to be one of the trig ratios. That's the only time that you need to do this step. So if you compare this example to the other two we did, okay, you can see the difference in terms of how we calculate it. All right. Okay, so moving along here, we're now going to look at the steps that we need to do in order to solve for an unknown angle. Now, for this one here, notice that I still have the same steps that on the right-hand side there, but this one over here, when we're solving for an angle, okay, the step to find the answer is going to be different. So again, just pay very close attention to this particular example here. All right. Okay, so step number 1, like I said, exactly the same. We're going to label the sides according to what we have here. Okay, so always label the hypotenuse first, especially if there's a number there. So if you look at the box here, the right angle, look across from it. Okay, we have hypotenuse. Now we're now looking at this angle A over here. Okay, so this A is the angle that we need to solve for. Now remember when you're trying to figure out whether something is the opposite or adjacent. Okay, remember that the side that is directly across from the given angle is always opposite. So if you draw an arrow like one I'm about to do and there's a number there, okay, that side will always be opposite and you should label it as that, okay? And again, when we have that, notice the steps are exactly the same so far. So we're going to use the sine ratio with one slight difference. Okay, when we put the numbers in here, okay, what we have here now is the A is what we're going to be solving for. So I want you to see what we're going to do here. Now, in the next step, what you could do is to take the 10 and to divide it by 15, okay, which gives me 0.6667, okay? What else you can, what you can also do, and I'm going to indicate it in the next step here, is in the next step, we're going to take what's called the inverse sine, okay? And the way you do that, okay, is to take the second function and press the sine key and then put in the 0.66667 in your calculator. Now, that will give you an accurate answer, good enough for what we need here. Alternate solution is if you take the inverse sine by pressing the second shift, okay, and then the sine, okay? And in brackets, you put in 10 divided by 15, and you close the brackets. You can actually get this answer without having to expressing it as a decimal in between. Okay, so that's another way to do it. So if you put in 10 divided by 15 inside a set of brackets, okay, sorry, after you press the second function and the sign, okay, you will you'll be able to get that answer in one less step. Okay, in fact, it'll be a more accurate answer in the end. Okay, so that's just a piece of advice if you want to shorten the number of steps. Okay, and at the same token, like I said, this is just rounded to 4 decimal places. Okay, what your calculator does, if you do it inside the brackets on its own, the 10 divided by 15 step, okay, it does all that for you. Okay, so again, that's just something that'll make the questions efficient, and it'll take a solution that takes 5 steps, turns it into 3. Okay, so that's just something I just want to put out there. All right, let's take a look at another example. Okay, this time we have another right angle triangle here. So always label the sides first before you do anything. So we're solving for angle B over here. So what we have here, looking across from the box, okay, notice what we have here is a hypotenuse. Now, as I said before, the next thing you need to determine is what side you have here, whether you have opposite or adjacent. So remember that the side directly across from the given angle, okay, is always opposite. Now, for this example over here, notice that if you try to look across from it like so, okay, you notice that there's no number there. Okay, so since there's no number or letter for that matter, okay, we don't need to label it. Now, this would have been the opposite. Okay, so since this would have been the opposite, that would make this as the adjacent. Okay, so again, that's just process of elimination. Like I said, it's one of the other strategies. Okay, so when you're solving this, okay, if you're not sure which one's opposite or adjacent, always just take a look at the side across from a given angle. Just remember that side is always opposite. Now, since there's no number there, you don't need to label it, so you would have to just label the other side as adjacent. Okay. So next part here, we're going to use the cosine ratio. Now, just make a note, one little tiny note here. I change it to the letter B because we're solving for the angle B here. Okay. All right. So the next thing, we're just going to put the numbers in. So we have 5 over 20. Now, from here, I'm going to put it as a decimal. Okay, by taking the 5 divided by 20. And last but not least, we take the inverse cosine, pressing the second function. Okay, and the cos this time. Okay, and that will give you an answer of 76 degrees there. Now, as I mentioned earlier, if you take the inverse cos and then put the 5 divided by 20 in brackets and then close the brackets, your calculator would do that in one less step there. Okay, so that's just a piece of advice just to shorten up some steps. All right, so let's take a look at some word problems here. And you can see here, well, we did this with the Pythagorean theorem too. Okay, so if this question sounds familiar, it does. The only difference is that we're looking at something else here. Okay, so ladder on the wall again. Okay, so what we have here is a 6-meter ladder is placed on a brick wall. Okay, like so. Now it tells us here, the only difference of this question is that we're given an angle in this one. So a 6-meter ladder, okay, is placed on a brick wall, labeled the 6 meters accordingly. And it says the angle between the floor and the ladder is 29 degrees. So what's this asking for over here is that the angle between the floor, okay, and the bottom of the ladder is going to be 29 degrees here. And what we want to do is we want to find out how far the foot of the ladder is from the wall. So we're in this question here, we're going to let x represent the bottom part of the right angle triangle, okay? Now remember what we want to do here is to label the sides accordingly here. So always look at the side directly across from the box, because remember that is always the hypotenuse. So the based on the location of 29 degrees and the x, okay, let's just do process of elimination here. Okay, if you look at the 29 degrees and you look across from it, okay, it's pointing to the wall. Now the wall doesn't have any numbers or letters, so there is no need to label it. However, the wall would have been the opposite. Okay, so since the opposite is here and there's nothing there, you would have to label the other side here, or the remaining side here, as adjacent. Okay, so we have adjacent and hypotenuse. Okay, so you always pick the ratio that has those two sides in it. So in this case here, it's going to be the cosine. Okay. Now remember, now that we're solving for the side length here, so let's put the numbers in. So adjacent will be x, hypotenuse will be 6, and this 29 degrees is going to go in for the capital A in this case. Now this next step here where you put the cos of 29, over 1. Again, you only do this when you're solving for the length of the sides. Notice that when we did the questions, when we're solving for the angles, that we did not do this step. Okay, so just make a note of that. Okay, and from here we cross multiply. Now, when we do this, okay, you can actually get the answer when you put this in your calculator, 6 cos 29 degrees. Okay, and you should get 5.2 meters. And don't forget that since this is a word problem, please provide a concluding statement, which includes the units. All right, so again, the ladder problem again. And guess what? We're not done with the ladder problems yet. Well, today we are, but not for another lesson, until another lesson here. All right, so last thing I want to do for today, okay, is now to determine the measure of an angle. And it says here, a storm caused a 15-foot hydro pole to lean over. The top of the pole is 12 feet above the ground, as you can see in the diagram here. So what we want to figure out here is we want to find the measure of the angle between the hydro pole and the ground, okay? And that's talking about this angle over here, angle P, okay? Now, based on the diagram, even though there's no box, okay, this angle G over here, that's where the box would be. If you want to ease your stress here, you might want to put a box there. That's up to you. So when we're labeling the sides here, again, what we have here, the 15 here would be the hypotenuse because the box would have been on the bottom right-hand corner here. So if you're looking at this angle P, okay, remember when you're trying to figure out what side is the opposite and which one is the adjacent, okay, remember the side across from the given angle is always going to be opposite. So sure enough, notice that when we go across, we do have a number there. So guess what? We're going to label that as our opposite, okay? So we have opposite of hypotenuse, so we're going to use the sine ratio to solve for that problem there, okay? All right, now notice again, I've replaced the A there with a P because that's the letter that we're using there. Okay, and we're going to put the numbers in as 12 over 15. Okay, and for the next step, I'm going to take the 12 divided by 15, and that gives me 0.8. Now remember that to solve for an angle, we have to now take the inverse sine, okay, of the 0.8 there. Okay, now just again, another reminder, another way you could have done this is you take the inverse sine, open up a set of brackets, and you did the step of 12 divided by 5 and then 12 divided by 15 and then closing the brackets, again, pressing equal sign, okay, and then you get the answer from there. So the angle between that's in between the hydropole and the ground is going to be 53 degrees. All right, so that wraps up the lesson on sine and cosine ratio. So again, I want you to get more practice on the sine and cosine ratio. Again, be able to label the sides, okay, for opposite, adjacent, and hypotenuse. Okay, so with sine and cosine ratio, remember that the hypotenuse was always there, so that's why we always labeled it first. Now, in the next lesson, we're going to look at the tan ratio, and the difficulty with that, and that's why it's a separate lesson, is that you do need to know the difference between opposite and adjacent. Okay, so as you go through the problems in this particular section over here, just ask yourself the question, how do we know which side is the opposite and which one is the adjacent? So remember when you're given an angle, okay, whether it's the angle itself or a letter to represent the angle that you're solving for, remember that the side directly across from that angle is always the opposite, okay? Now, when in doubt, okay, label all three sides. Okay, label the opposite, adjacent, hypotenuse. Hypotenuse, dead giveaway. Most of us know that it is directly across from the right angle. Okay, so label that first. Okay, and then label the remaining two. Okay, the one without a number or a letter. Okay, after you label the sides. Okay, what you do, you can cross it out. Erase it, do whatever. Okay, just make sure that you know the difference between opposite, adjacent, especially for the next lesson. Okay, and until then, I'll see you then.